Collaborative filtering is a technique that allows us to recommend products to users without having any product description data involved in the learning algorithm. There are a few different ways of doing this, and we've talked about that in the last few lectures. Let's now talk about a few common challenges that people encounter when trying to perform collaborative filtering. These challenges are the cold start problem, synonymy, gray sheep, data sparsity, and shilling attacks. We'll talk about all of these one by one in this class. The cold start problem talks about how we deal with products or users which don't have any history available. So if you have users who don't have any history, how do you provide recommendations for them? Synonymy is dealing with products which are basically the same but have different IDs or names. So since we don't have any descriptive data about the products, how do we identify this? These are similar in collaborative filtering. Shilling attacks talk about how you are dealing with users that are trying to game the system of recommendations. We've seen time and time again that the user item rating matrix is very sparse. So how do we solve that problem? Gray sheep are users whose opinions are not very consistent. And how does collaborating filtering affect these kind of users? Let's now go one by one into each of these challenges and see how we might solve for them. First, let's start with the cold start problem. This is one of the biggest problems if you try to use a pure collaborative filtering approach. Collaborative filtering relies on user history. It doesn't use any product description data or user demographics. Then what do we do when we have products or users with no history? Products which no users have rated yet, or users for whom there are no ratings yet. How do we find good recommendations for such products or users? The answer is to use content-boosted collaborative filtering. This is a combination of content-based filtering and collaborative filtering. This hybrid method is what helps us solve the cold start problem, where we don't have any rating history or purchasing or browsing history for a user. We could use product attributes like genre, the contents of the product, or user demographics to find similar users, and then augment collaborative filtering. So there is an inherent problem with recommendations for online stores. Online stores normally have a huge number of products, and they also have a huge number of users. Very few products are actually rated by multiple users. Very few users actually rate multiple products. So when you try to build a user item rating matrix and then try to do things like finding similarity between users or matrix factorization, you end up with a matrix which is very, very sparse. Overall, the data is very sparse. This becomes a problem because you end up with a very huge matrix where most of the products or most of the users don't really contribute anything to the learning process, but they make the learning process computationally inefficient or expensive. Dimensionality reduction comes to our rescue here. Using dimensionality reduction, we can help remove unimportant dimensions, unimportant users or products where we're not learning much, and then reduce the sparsity of the user item rating matrix, making the computational efficiency of your learning process much better. Gray sheep are users who are a little weird. There's nothing wrong with that. Every once in a while, some people are just special. John Lennon said that it's weird not to be weird. And most people are weird. So their opinions are not consistent. You cannot lump them in with a large group of people. Collaborative filtering relies on this idea that if two users have the same opinion about one thing, they might have a similar opinion about other things as well. But grey sheep are just people who don't have consistent opinions. So they might think that Star Wars 1 is really good, and so might another user. But if that other user thinks Star Wars 2 is also really good, this person might not agree. And this is something that might be pretty common. Now, pure collaborative filtering somehow doesn't work with these kind of users who are grey sheep and cannot be lumped with a group of users. For these kind of users, content-based filtering becomes important. So once again, for grey sheep, as we talked about with the cold start problem, content-boosted collaborative filtering would help. Synonymy is a problem which comes about because collaborative filtering doesn't have any data about products. What if some products are practically the same? Maybe they are different editions of a book, or maybe one is an ebook versus a physical copy. Both of these things are actually the same, but the store would have different product codes for each of these products. Now, if you just had some data for users, items, and ratings, which doesn't give you any product descriptions, you would lose out on this information. Lose out on saying that one user's rating for edition 1 of a product is same as another user's rating for edition 2 of the same product. This is actually why latent factor based collaborative filtering really works. It has been seen to identify synonyms really well. So if you have a set of data where you think that there might be synonymy, it's better to go for latent factor based collaborative filtering than a neighbor based collaborative filtering. Lastly, we'll just briefly touch upon shilling attacks. Shilling attacks are users who are trying to game the recommendation system. Maybe there are some authors who are giving tons of fake ratings for their own content, and they give tons of negative ratings for other people's content. Taking precautions against these makes the recommendation system more robust. If you just ignore the problem, you might end up giving importance to ratings which are fake ratings. So these are a few challenges that are commonly faced when people try to perform collaborative filtering. In the next class, we'll talk about association rules, another way to find recommendations, but this is slightly different kinds of recommendations from the ones that we've been talking about.